the second thing we need to check is how to use more of these frameworks, because they are so useful to convert information into useful knowledge. And so we will see a few examples through a case of inclusion. And we will use data from the same Kaggle 2018 survey. And here you have another chart. In this case, this chart shows us here, this is salary, and this is number of respondents. And here we have the salary distribution of data scientists. And the question is, how may we make more meaning out of this chart? I will ask you again, is this data, information, or knowledge? Well, that is information overload, so definitely it's not information or knowledge. So probably it's just still data. Right. So this chart was made by a user called Head or Tails, and he used the default settings of R, ggplot library, I think. And clearly we have information overload, too many things. I don't know where to look. Okay. So one solution here is to use what we call a visual metaphor. And if we turn this chart around like this, and then it looks like a pyramid, right? So we can take advantage of the powerful visual metaphor, which is the pyramid, and convert this chart, this is the same chart, to this one. Here, what we did is we reduced the number of colors to reduce the information overload. And now we kind of flipped the chart, and the income is here, right? So higher income at the top, gravity metaphor. And here we put a percentage of respondents instead of raw numbers of respondents. We put percentage, right? Right, so this chart is way more interesting because now it fits our very powerful visual metaphor of the pyramid, which we are very used to. And here now we can visualize and connect to the framework of the 1% of salaries and think about inclusion and how inclusive is the data science community salary-wise. And remember, just because you have a chart doesn't mean you cannot annotate things. So for example, we can annotate this chart and say, well, in the US, to belong to the 1%, one must earn $422,000 per year. That is true in the US. In New York is double, but that's interesting. So what does that tell us about data scientists? Is data scientists an elitistic group? Well, not in the US, right? Because very few people earn more than the 1%. However, if you look lower percentiles, like so to belong to the top 10% earners in the US, one needs to earn $166,000. And more or less about 6% of the respondents fit that description. So you could say that the data scientists more or less economically fit the same distribution as the US population. What about if we look at the global population? And remember, this survey is global. So then it turns out that, whoa, data scientists are an elite group globally, right? So that is very interesting. So here again, from a lot of data and information overload, we reduce the information overload first. We use a very powerful visual metaphor, the pyramid, and we connect to the 1% thinking framework. And we have created a very interesting chart from initially not so interesting data. Another challenge, same user, same survey data, 2018 Kaggle survey. And here we have, this chart is so typical. Here we have all the countries in the world and the number of data scientists in each country. Now, the question is, how may we make more meaning out of this chart? So by now, you might already know the answer. First, reduce information overload, right? So here's a hint. And then maybe we could cluster the countries, but how can we cluster the countries? Right? And another interesting hint is like whenever you can, try to look at the future. So what does that mean? So this is the number of data scientists in the year 2018. But Kaggle has also done this survey in 2017. So we could look at the difference, and this is what we did here, like change of users per country, right? And this is way more interesting because then we now have a picture of which countries are growing more. And here we still have a lot of information overload. So what the author decided to use here is to cluster the countries not by geographic location or continent, but by the BRICS framework. And the BRICS is a word invented 20 years ago by Goldman Sachs employee. It means Brazil, Russia, India, China, and somebody else, I forgot. So if we cluster the countries using BRICS, it's way more interesting because BRICS clusters countries by similar growth. So we now have the US as a block, the EU as a block, the rest of the nations as a block, and the BRIC countries, which is Brazil, Russia, India, and China, as a block. And then what we see if we look at growth, well, we see very interesting things. We see like, well, the US is the largest home to data scientists today. Well, it will not be in the future. So that's super interesting now. And then it's way less information overload, and this can be used. Imagine if you were Google, right, and you need to decide where to deploy advertisement of your Kaggle website, for example. Where do you deploy it? Well, right. Another solution to create more meaning out of this chart, which completely boring, is to use a thing from socioeconomics called data scientist prevalence. So in socioeconomics, you have prevalence of doctors per 10,000 population, and they use this to compare the quality of healthcare in each population, right? So we could do the same we could borrow this idea from socioeconomics to countries and then rank the countries. And then what we see is that, well, some countries, well, what would you see here? So here we have a number of data scientists that use Kaggle, yeah? So Kaggle survey respondents per 10,000 population, and here we have the countries. So if you'd like to marry a data scientist, then you should go to Singapore. That's what I'm thinking here, right? And here we can see the BRICS mean, EU mean, and USA mean. Very interesting. Good. Here we also reduce the number of colors. You could say that black and gray are two different colors, but you could say it's the same color. Right. Another iteration on the idea, and remember, we just started from this data, is to do a scatter plot and plot the countries, and then you have a 2D map, also known as a strategy map. And here we have decided to plot countries by prevalence of respondents and global innovation index. This is an index compiled by INSEAD every year, and they rank the countries by a formula of innovation. And it is very interesting that there's a high dependence on prevalence and innovation, right? And when you have these kind of maps and you have a correlation, we can do a linear regression, right? And then we can start forecasting where countries will go in the future, which is super interesting for policy making, right? So here's my challenge to you. If you had to predict where a country like Japan will be in the future in about 10, 20 years, where would you say Japan will be? So there's this physical law called mean reversion. It applies in many, many places. And you could apply or invoke the principle of mean reversion and saying that everything reverts to the mean. Stock market, apples that grow from trees, everybody, everything reverts to the mean. So you could say that Japan, in about 10, 20 years, would trend towards the linear regression here, which is exactly this direction. So you could say with high certainty that Japan will lose rank in the innovation index and that it will gain in prevalence of data scientists per 10,000 population. Right. So challenge for you, we saw a lot of slides, and how would you synthesize the last 20 slides? I give you 5 seconds, 1, 2, 3, 4, 5, done. All right, so we've seen 5 frameworks here. We've seen the prevalence framework from socioeconomics. We've seen the ranking countries on a 2D space from innovation. We've seen forecasting with mean reversion. It's another thinking framework. We have seen social classing with the inclusion and income chart. And we have seen clustering by using generations in the workplace from socioeconomics again. So we have seen 5 frameworks, and we saw that each time we connect our data to any of the frameworks, very interesting knowledge is created because we make the data useful. Because once you connect the data to some thinking framework, then it can be used very quickly. Right, to finish this session, I have a challenge for you. If you had to storytell the last 60 slides in a short animated visual that should go viral, how would you do it? And I'm going to give you a hint. There's this narrative called FUD, maybe you heard it. It's called Fear, Uncertainty, and Doubt narrative. And what this narrative does is to instill fear, uncertainty, and doubt in a story to advance a certain purpose. For example, this was used for IBM with the slogan, "Nobody gets fired for buying an IBM," right? It's being used by McKinsey, or maybe not McKinsey, but it's like an urban legend. Nobody gets fired for hiring McKinsey. And it was used by the tobacco industry, for example, in the 50s, 60s, and 70s to, to cast doubts on studies that show that tobacco was harming health of people. Right. If you had to summarize the last 60 slides with FUD narrative, how would you do it? Okay. So here's a small visual I prepared. Right. And so this is what will happen to you if you don't learn about data visualization frameworks and visual metaphors. All right. In the next session, we will see how to make your chart more appealing. I'll see you then.